Hello, everyone, and thanks for joining. My name is Tracy Cook, and I'm the online media manager for ModernAnalyst.com, the premier community for business analysts. I'd like to welcome you to today's webinar entitled Essential Requirements Practices. Today's webinar will last approximately 60 minutes, including the question and answer session at the end. Please be sure to submit your questions in advance using the questions feature of the GoToWebinar software. Today's feature speaker is Carl Wiegers. Carl is a principal consultant with Process Impact. He has a PhD in organic chemistry. Carl is the author of 14 books, including Software Requirements Essential, Software Requirements, Software Development Pearls, and the Thoughtless Design of Everyday Things. Carl has delivered more than 650 training courses, webinars, and conference presentations worldwide. Carl, welcome.
Thanks, Tracy. I appreciate the chance to be with you here today. So welcome, everybody, and thank you for joining us. I've been interested for a long time in how software teams can improve the ways they develop and manage their requirements. When I was a software developer at Kodak, remember Kodak? Around 1985, my team adopted a bunch of requirements practices. We started this technique called the product champion model that we found was very valuable for working with key customer representatives. We started writing structured requirements specifications, creating prototypes, and drawing analysis models. And we found that all of these approaches gave us better results than whatever it was we used to do before that. So this interest eventually led me to write several books on requirements, and I've also done a great deal of consulting and training in these areas. And one of the things that's interesting about being a consultant and trainer is you get to look over the shoulders of a lot of people to see what they're doing, and you can look for patterns of approaches that work well and approaches that don't work so well. So those all fed into the things that I've written about over the years. So the third edition of my book titled Software Requirements was pretty big, nearly 650 pages long. But it turns out that busy business analysts, requirements engineers, product owners, product managers don't always have the time to read a big book, although of course you only have to read the parts you care about. But I realized that I could distill down these dozens of practices that I talk about in this book and many other books also cover. I could distill that down into a core set of 20 requirements practices that I think every project team should perform. So Candace Hokanson and I wrote this much shorter book, Software Requirements Essentials. And you can see the cover there on the screen, but what you probably can't see is that it's pretty thin, but it's very concentrated. There's a lot of information in this short book. One important point is that these practices apply regardless of the type of product you're building or the development lifecycle the team is following. And in fact, Candace has a great deal of experience on agile projects, and so we've made sure that all of these practices are presented in a way that you can see how they would apply to either traditional or agile or hybrid approaches. And today I want to tell you about these core practices that we think are essential to BA success. As we go along, I suggest that you think about the extent to which each of these practices might apply to your situation and look for ways you could use them to improve your requirements or to reduce project risk. Let me also point at the bottom right here to the website for the book, SoftwareRex, that's REQS.com. I'll mention this a couple of times as we go along because there's a lot of useful information there. You can read reviews of the book, you can see some videos. In fact, I just recently launched a video series called The 1 Minute Analyst with a bunch of short videos coming out once a week. So you can access those there. And also you can download many useful checklists, templates, and spreadsheet tools and the like that I'll be mentioning some of those as we go along. So you can get all of that at softwarerex.com. So I am going to turn my camera off because I think it's just a distraction, but I'll be here and I'll come back at the end when we have some time for questions. So let me tell you what we're going to talk about here today. The 20 practices are grouped into 6 categories. First are 5 practices that lay a solid foundation for project success. And the other practices are all grouped into the 5 subdivisions of the domain of requirements engineering. There are 4 core practices on requirements elicitation, followed by 4 more on requirements analysis, another 4 on requirements specification, 1 on validating requirements, and finally 2 critical requirements management practices. And of course, these are by no means the only techniques that a skilled BA should have in their toolkit. The many big books that are available on requirements and business analysis describe dozens of additional practices. In fact, I think one of them has more than 100 practices in it. And these are all valuable in various situations, but I believe the 20 we're going to share with you today are the most important ones. Now, in this short presentation, I'm not going to describe all of these practices in detail, but I'll show you all the practices in each category, and then we'll drill down into one in each category. Important note, when I say the word requirements here, I'm referring to whatever kind of objects your project uses to represent information about stakeholder needs and to describe a solution's capabilities and characteristics. These kinds of knowledge cover a pretty wide range. They encompass business requirements, user requirements, functional and non-functional requirements. You might use use cases or user stories or talk about features, but whatever container, whatever object you use to represent this kind of knowledge in your project, that's what I mean when I say requirements. So if you don't use the word requirements or you don't like the word requirements, please just do that mental translation. Well, it turns out that every project has requirements. They may be stated or not. They may be carefully considered or not. They may be documented in some form or not. But a good set of requirements lets you answer some important and universal questions like these. I think everyone would like to know, why are we even working on this project? What are we trying to build? Who are we trying to satisfy? What do we implement first? What do we do after that? And what do we maybe never get to at all, and that's okay? How can we tell if our solution is good enough? And pretty much everybody would like to know, how do we tell when we're done? It's hard for me to think of a project, a team, or a group of stakeholders that wouldn't find the answers to these kinds of questions helpful. You might ask yourself, if someone asked you these questions about your project, would you be able to give good answers? I hope so. If not, that might be something to think about. Now, there are several actions you can take early in an initiative to get the information that lets you answer these kinds of questions. And that understanding helps the team lay the foundation for a successful project. It ensures that they address the right problem. It aligns everyone toward common objectives. It makes sure they engage the right participants, and it keeps, hopefully, the team's efforts all focused toward a common goal. These are the 5 practices we recommend to help all projects lay a solid foundation for success. Have you ever seen a project that built and delivered a solution only to discover that they were solving the wrong problem? That's not good. Organizations launch initiatives to solve some business problem or maybe to exploit an opportunity, but sometimes those problems or opportunities are not explicitly stated or documented. So it's a very good idea to understand the problem before converging on a solution. Don't presume that either a presented problem or a presented solution is necessarily correct. Instead, I'm a big fan of doing some root cause analysis to make sure the problem is well understood and that our proposed solution makes sense. The stakeholders need to understand why this initiative is being launched and its business objectives. I'll talk more about this very shortly. When you launch a new initiative, you might not know where to draw the line between what the solution should and should not include. So an important foundational practice is to establish that what's in, what's out boundary. It's a kind of solution scoping action. Every project has its stakeholders. These are individuals or groups who are actively involved in a project, are affected by it, or can influence its direction. You need to cast a large net to identify many potential stakeholders. Then you can decide who can best represent the needs of each stakeholder group and consider how the team will engage with them. Every project faces many requirements-related decisions. These include things like resolving conflicts, both within and across user classes, prioritizing requirements, evaluating proposed requirement changes, and so forth. So it's important to determine who the decision makers will be for these requirements issues, preferably before the group confronts their first significant decision. And each group also needs to choose a decision rule that they'll use when they're resolving issues. So these are all important for laying the foundation, but let's take a closer look at practice number 2, defining the business objectives. I think understanding the business problem or opportunity is an essential first step toward both product and project success. The next step is to describe exactly what the project sponsor or other important stakeholders expect the solution to accomplish. Those are the business objectives. Business objectives can be financial or non-financial. They could be internal, like operations, or outward-facing, like products. They could be strategic or tactical. It's also a good idea to define some success metrics so you can tell if you have achieved or at least are on the path to achieving those objectives. These kinds of business-oriented requirements lead the group to define a solution concept that you're confident will satisfy the business objectives, along with identifying the scope and limitations that bound the solution. I like this phrase, scope and limitations. I actually got that from my background as an organic chemist. Whenever an organic chemist comes up with a new reaction that changes chemical A type into chemical B type, they write a paper. And part of that paper is scope and limitations. What does the reaction do? What does the reaction not do? And I think we should think about software projects the same way. Scope is what's in, limitations are what's out. And so it's a good idea to explicitly identify things that someone might expect would be part of the solution, but we've made a conscious, good business decision to decide to exclude that. That is really a form of expectation management. So a clear set of business objectives then helps the team elicit the detailed requirements that are going to describe the solution's capabilities and characteristics. These objectives help the team identify its key stakeholders who can work with the BA to understand their needs and then to define the necessary solution functionality. Decision makers can set the priorities of individual requirements, and they, very importantly, define the contents of each development increment or product release so that they align with achieving the most important and most timely business objectives. So this is a really important part of it, and I think it's often overlooked. Business objectives let you determine when the business problem is solved, or a need is fulfilled, or an opportunity is exploited. Now, it's easy to state vague goals, but you're better off trying to write your objectives to be specific, quantitative, and measurable, because otherwise, I don't know how you tell if you've achieved them. A tool that will help us with this is called the Business Objectives Model. This is a valuable tool for a thorough analysis of complex problems in which you might have multiple business problems and business objectives all intertwined. So the Business Objectives Model visually links problems to objectives, to their associated success metrics, and to the resultant solution concept. So here's a partial example for a proposed restaurant online ordering system. Here's our first business problem, which is that we're not getting enough revenue from a particular target market. Although exactly how the restaurant knows how old their customers are isn't totally clear to me, but okay, I can see how you might be aiming your products at a certain market demographic, and maybe you're not getting as much revenue from that as you'd think you'd like to. And so that leads to an objective that we'd like to achieve. We want to increase our monthly revenue from that key target market to a certain amount. And as we think through the restaurant's business situation, we uncover additional problems and their corresponding business objectives. And notice that all of these have numbers in them. They're quantitative, and that gives us something to measure rather than just saying improve or increase without being more precise. And our analysis eventually leads us to conceive a solution that would address all those problems and hopefully achieve our desired business objectives. So you can see how to tie major solution features back to the business outcomes that you want to achieve. And here's a little safety tip. If you find that you've got features included in your solution concept and you cannot tie those back to some business objective, you might ask yourself, why are we building that? I think this kind of analysis is much better than thinking of a cool looking solution first and just hoping it will give you the business outcomes that you desire. Well, the first step in dealing with the requirements is to get some. People often speak of gathering requirements, but I don't like that phrase and I try not to use it. It's not just a simple collection process, and a better term for this activity is requirements elicitation. Elicitation does certainly include some collection, but it also involves exploring, discovering, and even inventing requirements. Requirements can come from many sources, so the BA needs to look for requirements from various user representatives, subject matter experts, and other stakeholders. You might look at documentation about your business processes, current systems, and maybe competing products. There are probably some applicable laws and business policies that you need to be aware of, user problem reports, and all sorts of places you might get information that help guide you into determining what to build. So there are a lot of places and ways to look for requirements. The skilled BA has a lot of elicitation techniques in their toolkit, and they know which hammer do I pull out for each nail that I'm facing. What's the right technique to use in a particular situation. They might do individual interviews with stakeholders. Facilitated group workshops are very effective in many cases. You can learn a lot by watching users do their work. You can use surveys or questionnaires to get more quantitative kinds of information. Process modeling is valuable, and many others too. So we need to think of a lot of ways that we're going to go about collecting information that we can use to determine what to build. So here are 4 core requirements elicitation practices. On the next slide, we're going to talk about what I think is a very important point, understanding what users need to do with the solution. So my previous book was called Software Development Pearls. It's got 60 lessons I've learned in the more than 50 years since I started to learn how to program computers. And somebody asked me a little while ago, what's the most important lesson you've learned about software development in your career? And I thought about it, and this is it. I think it's understanding what users need to do with the solution. I think that is very central. So we're going to talk about that for a little bit. All systems react to various kinds of events that trigger some response. So event and response analysis is valuable. There could be business events that launch a use case, signal events like inputs from a switch or a sensor, or maybe a particular data value. Maybe your inventory of some product reaches a certain number and you want to trigger some reorder to get your inventory back up. And you can have temporal or time-triggered events that lead to some system behavior. This is especially important with real-time systems. Also, all software systems process data, so you should assess your data concepts and their relationships. Data modeling is a powerful technique for this purpose. And besides functionality, which is sort of obvious, for every product you need to explore quality attributes. These are a category of non-functional requirements. And there are often trade-offs between these quality characteristics that mean you cannot optimize all of them at once. And for that reason, we need to do a good job of understanding those during requirements elicitation so that designers get the information they need to make good trade-off decisions. So if you were holding a requirements elicitation discussion with some users, maybe like the new user shown here, about some information system, which of the following questions do you think would yield the greatest insights? Should we ask, what do you want? Or how about, what are your requirements? Maybe we should ask, what do you want the system to do? Or what features would you like to see in the system? Those questions will all get you somewhere, but I think a better question is, what do you need to do with the solution? That shifts the focus of the discussion from an emphasis on the product to a focus on users, and more specifically on usage. People talk a lot about user-centric design or requirements, but I think the key term is usage, not user-centric. Let's understand what people need to do. One reason this is valuable is because focusing on features during elicitation can lead the team to implement incomplete functionality that doesn't let users do all the things they have to do, because we didn't really talk about those usage modes. So you're probably familiar with the IIBA's 3-level model of requirements, with business requirements at the top and stakeholder requirements in the middle and solution requirements at the bottom. Well, I have a very similar 3-level model, which I developed several years before there was an IIBA, and I don't really like that stakeholder requirements in the middle in the model, because as far as I can tell, all requirements come from some stakeholder. But here we are specifically talking about user requirements, requirements from that subset of stakeholders who will actually use the solution in some way. So we want to make sure our user requirements align with achieving the project's business objectives. Of course, this implies that you have already defined the business objectives first, as we saw a few minutes ago. People naturally focus on describing the way the system's going to function when all goes well, sometimes called the happy path. But in addition to exploring these normal success scenarios, you also need to consider alternative ways the user might try to accomplish a task, as well as exceptions that might prevent successful completion. So from an understanding of the user requirements, the BA can identify the necessary functionality that the solution must include to let users get the job done. Also, by making sure that the specified functionality aligns with known user tasks, you can avoid a common problem. You're less likely to waste time and effort implementing functionality that seems like a good idea at the time, but doesn't get used. Have you ever had that happen on a project? People tell you they need certain functionality, or someone has an idea and you say, yeah, that'd be cool, let's put that in. And then nobody, or almost nobody, uses it. I've had that happen, and it's kind of annoying because you work hard building the functionality that doesn't get used, just like you did on that does. So by focusing on known usage, you can do a better job of avoiding unnecessary functionality. So none of those are perfect solutions, but I think this gets you farther along than you might otherwise. Two commonly used techniques for exploring user requirements are use cases and user stories. It can be a bit challenging to steer elicitation participants from thinking about product features, which is more obvious, to focusing on usage. But use cases provide a nicely structured way to facilitate that change in the thought process. The name of a use case defines a goal the user is trying to accomplish. So maybe someone who posts articles on some kind of publication platform or blog wants to view article statistics. I do this. I have about 100 articles on my medium.com account on a lot of topics, and I look at the article statistics regularly. So that becomes a use case name, view article statistics. Here's a little tip. Whenever an elicitation participant says, I want to do something, or I need to be able to do something, that do something likely is a use case. A use case template contains categories to fully describe the use case. You'll probably have to state some preconditions that must be satisfied before the system could execute the use case, postconditions that are true after successful completion. You might want to describe the steps that take place in a dialogue between the user and the system, how to handle things that can go wrong, pertinent business rules, and so forth. And then the BA can derive all the necessary functional requirements that developers must implement to realize the use case. Very powerful also, at least it really impressed me when I first figured this out, is that you can create tests from the use case specification as well. That's a really powerful quality aid. We're going to come back to the idea of testing requirements a little later. I'm sorry to have to keep giving you forward references to things that we will talk about later. I've been giving presentations and training for many years, but I've never learned how to say everything simultaneously, but we'll cover these things. User stories are typically employed on agile projects as the primary requirements deliverable. A user story is written typically according to a pattern that provides a little more information and context, including the type of user and the motivation or rationale behind the request. So for that same need regarding article statistics, we might say, as an author, okay, now I know who cares about this. I want to view the statistics for my articles. That's basically the same as the use case name, so that I can see which topics my readers enjoy the most. All right, so that gives us a richer understanding than just the use case name does. Now, rather than writing detailed functional requirements, agile projects typically provide the story details through a set of acceptance criteria the implemented story must satisfy. Keep in mind, requirements and tests are complementary thought processes. They show the same information in different ways, Either can be fine so long as we properly communicate the information developers need to know. And I think that's an important point. I do not like the term agile requirements. I don't believe there is such a thing as agile requirements because that implies that somehow the information you need to build software on an agile project is different from the information developers need to build it on a traditional project. I don't think that's true. Developers need the same information. There's certainly changes in differences in how agile projects handle those compared to traditional projects, but they need the same information. And whether you choose to write it as acceptance criteria or functional requirements specifications doesn't really matter very much. But with both use cases and user stories, keep the focus on understanding user goals initially, not describing bits of system functionality. Well, once you've elicited some requirements, you need to analyze them. But what exactly does it mean to analyze requirements? Analysis sounds like something that just kind of happens through staring at requirements long enough. But in reality, you can use several techniques to search for specific problems and to produce better requirements and hopefully better solutions. Analyzing requirements is where a skilled BA really adds value. Keep in mind that analysis is an incremental and iterative process. It's interwoven with ongoing requirements elicitation, specification, and validation activities. But at heart, requirements analysis involves ensuring that the needs of all stakeholders are understood and documented appropriately, whatever that means in your world. And the outcome of successful analysis ensures that we can build a satisfactory solution. We can define it, agree upon it, build it, and test it, something that'll meet those needs. Analysis involves multiple thought processes to confirm completeness, clarity, and correctness. You ask questions to make sure you understand what each requirement is saying. You might represent information in multiple ways, and then you can compare those multiple representations to find errors and fill in gaps in your knowledge. And along the way, you're confirming and refining your knowledge. So there are 4 essential requirements analysis practices. First is simply to analyze both individual requirements and sets of requirements. I'll discuss this further in a moment. I am a huge fan of requirements modeling. Drawing visual diagrams of requirements, I think, is an especially powerful technique. So when I first took a course on structured analysis and design long ago, it really changed how I approached software development in general. I'd never thought of drawing pictures to learn more about your problem and your solution before you actually started writing code. So that was a really eye-opening insight for me. Powerful method. People often create prototypes, which are possible or preliminary or partial implementations to better understand the problem and to refine and validate requirements for some part of the solution. Unfortunately, no team can implement all of its requirements simultaneously, so they must prioritize them to make sure the team delivers the most important capabilities in the right sequence to maximize the delivered value. So here are the major aspects of analyzing individual requirements. You should be able to trace each requirement or user story back to its origin. That could be a stakeholder request, maybe a policy, a quality attribute, or some other source that led to including it. And if anyone asks why a particular requirement is present, the BA should have a compelling answer. A big aspect of analysis is to decompose large or high-level requirements into a sufficient level of detail. Analysis also includes deriving functional requirements and data requirements from the bits of a use case, a story, business rules, or other sources. If you've done development, you know that developers write a lot of code to handle exceptions that could prevent successful execution. So during analysis, identify potential error conditions, which could be user actions, system conditions, or data values that the system must detect and handle. Experienced BAs automatically scan for certain characteristics as they review requirements. They should be correct, complete, feasible, necessary, unambiguous, and so on. We've all seen those lists. You're never going to get perfect requirements, but if you keep those characteristics in mind as you write and review them, you will get better requirements. Consider how someone could judge whether the requirement was correctly implemented and ready for use. That's its acceptance criteria. People often make unstated assumptions regarding requirements, but conflicting and obsolete assumptions can cause problems later. Constraints restrict the developer's design or implementation options. Confirm whether any constraints you see embedded in requirements are truly restrictions or just solution ideas that someone proposed. Business rules often influence or serve as the source of specific pieces of functionality or data. It's important to know which rules apply to which processes, functions, and data objects. We'll come back to business rules later on. Any product that poses safety risks must include hazard analysis as part of the requirements analysis. And think about the risks that any requirement could pose to the project's success. Finally, requirements reuse involves both crafting requirements that can be reused in other contexts, as well as finding existing functionality that your application could exploit. So consider both reuse aspects during analysis. Other aspects of analysis assess sets of requirements. It's hard to see the requirements that aren't there. They're invisible. So finding missing requirements kind of involves reading between the lines. To help assess completeness, trace downward from your business objectives through to solution requirements to ensure that everything aligns properly. Inconsistencies can arise between a parent requirement and its children. Requirements of the same type also could conflict. One says to do A, another says to do B, but it's logically impossible to do both. Look for multiple instances of the same information. I once reviewed several use cases that had nearly, but not exactly, the same data structure definition in 3 places. So the reader doesn't know which one of those to believe, if any. They could all be wrong, but they can't all be right. Replication also raises the risk of generating an inconsistency if you end up changing one instance, but not the others. So it's better to point to a single source of the information instead of duplicating it. Some requirements depend on others being implemented at the same time or previously. For instance, it only makes sense to implement exception handling code concurrently with the functionality where the error could occur. Beyond these desirable characteristics I mentioned earlier of completeness and consistency, make sure that groups of requirements are written and labeled in a way to be modifiable over time and traceable. Creating multiple representations of requirements using different thought processes lets you compare them to find problems. This is really powerful. If you only record requirements knowledge in one form, no matter what form that is, whether they're user stories or functionality or pictures, if you only represent it in one form, you must believe it. But if you represent it in more than one form, such as requirements and tests, then you can compare those and you'll find errors, I guarantee it. Earlier, I mentioned the importance of prioritizing requirements. And finally, stakeholders sometimes assume that the solution will include certain functionality without them having to say so explicitly. But I have found that telepathy and clairvoyance are not effective requirements elicitation techniques. So these analysis techniques will become second nature eventually as you get in the habit of applying them. But until you do, it's helpful to have checklists. So if you go to our website, softwarerex.com, you can download checklists that will remind you of these various analysis practices, as well as a number of other checklists. And actually, something I forgot to mention, you can download a short article that talks about the business objectives model also from the Software Rex website. So the term requirements specification refers both to the recording of requirements knowledge and to the deliverables you might produce, such as a software requirements specification. And here we have a picture of one of the world's earliest business analysts carefully writing some requirements. Actually, that's Charles Dickens, but close enough. Now, I want to ask you to do something here. Whenever you hear the phrase writing requirements, please mentally change that to representing requirements knowledge. Natural language text, which is implied by writing requirements, is certainly the most popular way to record software requirements because that's how people normally communicate. But there are many other alternatives like tables, these visual models, tests, screen designs, prototypes, and mathematical expressions. Now, some people don't like to write requirements. They object to that. But I always try to remember that the cost of recording knowledge is small compared to the cost of acquiring that knowledge or reacquiring it in the future. The hard part isn't writing the requirements. The hard part is figuring out what they are. If we rely on human memories, we have a problem because those are imperfect and incomplete. Memories fade and distort over time, and other people can't access them. So I don't have a lot of patience with people who aren't interested in writing requirements because documented requirements constitute a kind of persistent group memory. Requirements can be stored in many different structures. You typically think of documents, but they could also be spreadsheets or a database, maybe a requirements management tool or stickies on a wall, whatever works for you. They vary in the information they contain, how that information is organized, how much detail is included, and so forth. So think of your requirements spec simply as being a container for requirements related knowledge, no matter what its form is. Very important to keep in mind that the goal of writing any kind of requirements is always clear and effective communication. It's not following a rule book or rigidly following a particular pattern or doing things that are the most popular in the literature today. It's clear and effective communication, and there are many ways to achieve that. Two core specification practices are to write the various kinds of requirements in consistent ways according to recognizable patterns, and to organize that information in a structured fashion with the help of a template. I'm going to talk in a moment about the importance of identifying and documenting business rules. In fact, I just posted on my medium.com account this week an article about business rules. A common vocabulary helps the participants avoid misunderstandings, so each project should accumulate a glossary of significant terms, abbreviations, acronyms, and synonyms to make sure that everyone understands them in the same way. Well, let me tell you a little story. My friend Jeremy visited his local blood bank's website recently and made an appointment to donate blood later that day. Good for Jeremy. But when Jeremy arrived at the blood bank, the staff told him that they didn't take same-day appointments, even though the website let him make that appointment. Jeremy was annoyed. Business rules are statements that define or restrict certain aspects of an organization's operations, or they influence the behaviors of people and systems within the organization. They're not software requirements themselves, but business rules often lead to derived requirements to enforce or comply with the rule. And as such, they're a critical piece of the requirements puzzle on every project. The blood bank's website developers kind of dropped the ball on that issue by not enforcing the no same-day appointment policy. There are several types of business rules. Some simply state facts about the business. Many rules impose constraints on who can do what under what conditions. Action enablers trigger some system or business behavior. And obviously, computations describe how to perform certain calculations. Business rules can come from various sources. Company policies constitute a large source, like a store's policies for issuing refunds. Many products and systems have to comply with various laws and regulations. Industry standards, like interface standards, are another source of business rules. But too often, business rules are not documented at all, or they're embedded in the code. It's better to document business rules like you would document requirements. They should be clear, complete, consistent, unambiguous, and so forth. Business rules also are subject to the same problems that can afflict requirements. One rule could conflict or overlap with another. A rule might be obsolete or based on assumptions that are no longer valid. Rules could be imprecise or fail to cover certain conditions. And as with requirements, textual rules aren't always the best way to communicate information. Suppose you have an online store and it offers various combinations of discounts and free shipping, depending on the total price of an order and whether the customer is a club member. You could write out all those rules in natural language, but displaying them in the form of a decision table like this is easier to understand. The decision table shows all the possible combinations of conditions and the resulting actions. So here are two sets of conditions, the amount of the order total and whether or not the customer is a club member. And below that are the various actions that would result from the various combinations of conditions. And the X just indicates that that particular outcome applies to that combination. So for example, let's look at rule discount 5 here. It says if the order total is in the range of $50 to $100 inclusive, and the customer is a club member, then they get a 10% discount and free shipping. So representing business logic with decision tables helps to avoid boundary value problems. You might find that you have one rule that says, gee, something happens if it's less than 50, and another rule that says what happens if it's more than 50, but what about exactly 50? You could miss that. That's a boundary value problem. And you can have missing logical combinations that the decision table helps you avoid. So this compact table format is easier to create, to read, and to modify than a repetitive set of very similar rules. And the decision table also facilitates test design to ensure that no combinations of conditions are missed. I really like these kinds of simple tools that have broad use in many situations. So by this point in the requirements development process, where are we? Well, we understand the project's business objectives. You've elicited requirements for some portion of the solution from various stakeholders. You've analyzed those. You've recorded them in some form, and now the team's ready to begin development on that portion of the product, right? Maybe. Yes, you have some requirements, but how do you know they're the right requirements? Are you confident they'll meet the user's goals and address the business situation that led to launching the initiative in the first place? You could have a set of beautifully written and modeled requirements that appear to be crystal clear, complete, and unambiguous, and yet they could still be wrong. So requirements validation activities strive to confirm that some set of requirements accurately describe stakeholder needs and to confirm that a solution based on those requirements would indeed satisfy those needs and achieve the intended business objectives. The terms verification and validation are often confused or misused. Verification confirms that whatever you've done was done correctly and to specification. Validation ensures that you're doing the right thing. So again, requirements validation activities like analysis are all interwoven with the ongoing elicitation, analysis, and specification work. These things all thread together. You have to treat requirements development as an iterative and incremental activity. Prototypes and early releases of your solution, or even delivering the full solution, those are ways to validate with customers whether or not you're building the correct solution. But those can be rather expensive activities, and you don't get much feedback until you've actually built something. So a core practice for ongoing requirements validation involves a combination of reviewing requirements and testing them before you have any code. Peer review of documented requirements is a powerful quality practice. In a peer review, some colleagues of the person who created a requirements artifact examine it for potential defects and other issues. Reviews are a high leverage investment in software quality, and requirements reviews offer the highest leverage of all. I've been a fan of reviews for a long time. I wrote a book called Peer Reviews in Software some years ago, and it's also an indication of an organization's culture, whether or not they perform reviews, whether or not they're comfortable having colleagues look over the work they've done to help them make it better and find errors. And I frankly would not want to work in an organization in which peer reviews were not just an intrinsic part of the way the culture is steering people to behave. So here are a few tips. You need to choose the right review participants. A BA might invite another analyst to review their requirements because that other BA knows what kind of problems to look for. However, that other BA can't tell if the requirements properly address the business need. And I ran into this myself many times. As a consultant, I reviewed a whole lot of requirements documents for companies, but I didn't always have the business rationale to be able to make sure that this was going to describe a solution for their need. I just couldn't make that judgment. I couldn't validate those requirements. So to validate the requirements, you also need reviewers who supplied the information that led to the requirements. These could be representatives of various user classes, maybe marketing staff, and the author of any higher level or predecessor system specification. Finally, people who must base their work on the requirements. I call them victims of the requirements. They also make good reviewers. Architects, designers, data analysts, developers, testers, they'll all find different kinds of issues. There are several forms of reviews that span a range of formality and rigor, so you need to choose the right approach for a given situation. The simplest review just involves asking a colleague to look over something you've created. That's an ad hoc review. In a pass around, you invite several people to examine some requirements or diagrams. A team review and an inspection are more structured and more formal, which makes them slower and more expensive, but also more thorough and more valuable. There's trade-off. Reviewers can use a checklist to remind them of common types of requirements, problems to look for, like the usual offenders here, ambiguities, and so forth. Again, with experience, you'll internalize this list, but in the meantime, a checklist is helpful, and you can download a requirements review checklist from the website for the book, softwarerex.com. Now, I learned a long time ago, you can begin testing your software as soon as you define your first requirement. That was a real eye-opener for me when I first realized it. Requirements describe what to build and how the solution should behave in various conditions. Tests describe how to tell if the solution is exhibiting the correct behavior and define situations where it does not. So long ago, I discovered that writing tests from my mental image of how the system should behave is a different thought process than writing requirements. So I would do both. And then after writing tests, I would walk through them against the requirements to make sure that every test could be performed by firing off certain requirements. Every time I did that, I found errors. I might find missing and erroneous requirements, missing and erroneous tests. So I could fix all that stuff quickly and cheaply. It's even better if you can use two entirely separate brains to write the requirements and the tests, starting from the same information sources, like a use case or some stories. That's a good way to discover ambiguities where people interpret something differently, or gaps. Agile teams often write acceptance criteria in the form of acceptance tests to define a user story's details. Those tests help developers understand what to implement and how to tell if they're done. And the tests also can help users envision whether a story will meet their needs, and that's the essence of requirements validation. A popular way to write acceptance tests uses the given, when, then pattern. Think back to the user story we saw earlier. As an author, I want to view the statistics for my articles so that I can see which topics my readers enjoy the most. Well, here's one acceptance test you might write for that story. We give it an ID, AT1. Given that I am logged into the platform and I have articles published, when there's a trigger, I request to view statistics, then some things happen. I see a graph of my total article view statistics for the past 30 days and some blah, blah, blah details. So this is how you can precisely define what should happen under these circumstances. It's a nice way to write tests. Now, here's another way you can use test thinking to validate your requirements, again, before writing any code. Suppose you've drawn a model to complement some of your textual requirements. You can trace the logical execution path on the model with a highlighter pen as you walk through the tests and see if the system would behave as you expect. After you go through all the tests with your highlighter, look for some problems. If there's a path in the model that isn't highlighted, that could indicate either that you're missing a test to force that path, or that that path does not reflect a legitimate requirement or legitimate system behavior. Conversely, if a test has no corresponding path to trace in the model, either the test is invalid or the model's incomplete. Either way, that disconnect tells you there's a problem. So here's an example. This is a portion of a process flow diagram for a website that lets sales representatives enter orders for a customer who's on the phone. In one scenario, the customer's requested items are all out of stock. So we're asking here if the item's in stock. And no, all right, sorry. Do you want something else? And you cycle around this way until they say they're done. Well, what if they never have anything that's in stock? Okay, well, among many others, the tester has written this test. Given that the cart is empty, because everything was out of stock, when the customer declines to order more items, then the process should terminate. Makes sense. Now, if you try to trace the path that this test describes on the process flow, you can't do it. The diagram says that if the requested items are not in stock and the customer doesn't want to order anything else, so the cart's empty, the sales rep still sends an empty quote to the customer. That doesn't match the test, but it also doesn't make sense. So if we assume the test is correct, we found an error in the model and in any textual requirements that align with the model. That's a good thing. So maybe we take that information and we decide, all right, let's see if we can fix our model to make more sense so we can execute that test. You redraw that portion of the model to look like this. We now have this blue diamond, which checks to see if the cart contains items following the end of that customer and sales rep dialogue. If so, it sends the quote. If not, then it ends the process. Let's go back to that same test. Now you can trace that path on the process flow, ending the sales process instead of sending the customer a meaningless quote with nothing in it. So I think finding errors like this one before the team writes the code and before the customer encounters a problem is a good thing. You might have noticed that customers are never in a good mood when they report a problem. Let's try to avoid those conversations. All right, so far I have described 18 practices that help you develop a set of high quality solution requirements. Once you have those fine requirements in hand, now what happens to them? Well, requirements management is the subdomain of requirements engineering that deals with how requirements are used on the project and how the project responds to evolving needs. Requirements management involves several ongoing activities. You need to track versions of individual requirements as they change over time. Similarly, the status of each individual requirement changes over time. It goes from being proposed to approved to ultimately being either verified as correctly implemented in the product, or it might be deferred or deleted. If you're serious about requirements management, you'll trace each requirement both backward to its origin and forward to design elements, code, and tests that show where it was implemented in the solution. These are all valuable, but the two most important requirements management practices that apply to every project are establishing and maintaining or managing requirements baselines, I didn't say that clearly, and managing changes to requirements effectively. You need to have mechanisms in place to add new requirements that come along, to modify existing ones, and to delete planned requirements from your backlog of pending work. So let's say a little bit about the requirements baseline. At some point, as the BA, you've developed a set of requirements and confirmed that they describe a suitable solution. The next step is for the development team to commit to implementing a subset of those requirements in a specific time frame or development cycle. And that's all a requirements baseline is. It's an agreement. Establishing the baseline isn't a freeze. It doesn't mean that change won't happen. It will. But the baseline assures everyone involved that the team can move forward with development of that part of the product at a low risk of major changes. A sensible baselining and change management approach assures that everyone always knows what they should and should not be working on. You can define a baseline in two ways. A time-bound baseline begins by establishing a time box. This is common on agile projects. That could be a single iteration or a group of iterations, maybe a planned release, or even an entire product. The team then allocates the highest priority requirements from their backlog to the baseline until the time box's development and testing capacities are filled. In contrast, a scope-bound baseline consists of a logically grouped set of features, requirements, or stories that can be built, tested, and deployed together and are approved as a unit. With a scope-bound approach, you establish the requirements baseline without necessarily knowing its size or delivery schedule. But regardless, a baseline serves as the reference point for commencing change control of the committed requirements. Your team should follow its defined requirements change process to make sure the right people make the right decisions. And here's the part nobody likes. This often requires negotiating changes in scope, time, and resources for the work. Nobody likes that, but it's just reality, and we sort of have to deal with reality. One way you can get some help here is to include contingency buffers to provide some slack time to accommodate a reasonable amount of change. Otherwise, the first new or changed requirement that comes along, or any other project surprises, can disrupt your plans and commitments. So I've covered a lot of ground quickly here today. I hope you've made some notes of practices that you feel would add value to your project, would reduce risk, or increase the chance of success. I cannot promise you that if you perform these 20 practices on your projects, you'll definitely be successful, but I can promise you that you'll have fewer requirements related headaches if you do, and that seems to me to be a strong enough motivation to look into them and see if any of these practices would help your teams beef up the ways they plan, manage, and develop their requirements. Now, if this seems interesting to you, here's an offer from the publisher. Addison Wesley is the publisher of this book, and at their website, informit.com/softwarerex, you've got a discount code here that you can use during checkout to save a few bucks on either the ebook or the paperback. So with that, let's turn it back to Tracy and see if we have any questions to talk about.
Thank you, Carl. We do have questions. Just a reminder, you can try and submit your questions using the questions box right now. Carl, thanks so much for yet another great informative session. I'm going to jump right into the questions and we're going to try and get through as many as we can. First, can we use use case modeling for agile products?
Of course. It's not a rule that you can't do this or that on any project. As far as I'm concerned, you should use any techniques in your toolkit that you find valuable for the work that you're doing. There's no agile police that are going to come tell you you can't do that. And if there are, then they're wrong, in my opinion. So yes, use cases can work just fine on agile projects.
Thanks, Carl. Our next question. Writing tests could verify requirements, but what about the software? Shouldn't it be first made before testing?
Well, depends on what you're looking for. If you're trying to determine whether the software has been implemented correctly, certainly you need to have some software to test first. But what I'm suggesting is that you take some of the effort that you might use at the end for testing and you reallocate that is shift it to the left of the project's time scale. You reallocate that to earlier in the project to say, let's think about testing conceptually our requirements to see if in fact they're going to behave the way we want them to, or maybe we don't even need them, or maybe we're missing some because we have this idea for a test of how the system should behave, regardless of what code you end up writing. We have an idea, a thought of how it ought to work, and then when you think about how to test that, you realize I'm missing a requirement that will let that happen. Wouldn't you rather find out about that early instead of when you think you're done and you're just frantically trying to deliver the product to the customer? I would. So we're reallocating some effort, and that's not wasted effort. Those conceptual tests that you're using to validate your requirements can then turn into or grow into specific test procedures once you have user interfaces and code built so that you can say, well, how do I execute this test? You're not doing extra work, you're reallocating work, and I'm pretty sure you're going to come out ahead when you do that, with a lot of errors being caught earlier than they might have been otherwise detected.
Thank you, Carl. It is the top of the hour for anyone that needs to leave, and I'm just going to try and get in one, possibly two more questions before we wrap up. Carl, what are the characteristics of a good requirement?
Well, there's the standard sorts of lists. They're complete, they're unambiguous, they're correct, they're testable, and so forth. There are lists like that in a lot of books. For example, in my book, Software Requirements, 3rd edition, there's a list of 10 or 12 characteristics that requirements should exhibit. But remember our overall goal: clear and effective communication. And there are multiple ways that you can do that, and anything that accomplishes that is going to be a characteristic of a good requirement. Any place where you haven't accomplished that, any case where people aren't sure about what to do, or people have different understandings, or people are missing information they have to go try to figure out or make up or track down, that wasn't a good enough requirement.
Thank you, Carl. I think we're going to have one more question. Should we say non-functional requirements are children of functional requirements?
No, I wouldn't say that. Non-functional requirements talk about not what the product does, but how well it does the things that it does. And it would actually go the other way. Non-functional requirements are often the origin or parent of functional requirements. For example, you might have some security requirements that you state in terms of who can do what, when, and what can't happen, and how users have to authenticate their identity and so forth. Well, that turns into a lot of functional requirements to make that happen in the product. So I would actually say it the other way, that the non-functional requirements tend to be the parents of some of the functional requirements that make those happen, that make those product have those desired characteristics.
Thank you, Carl. Thank you again for such a great presentation. We
My
have run
pleasure.
out of time. I'm just going to share this one comment with you. Awesome presentation, very valuable, and I can
Great.
assure you that you have given great input, judging by the mistakes I have made without knowing them.
Well, how do you
So,
think I learned all this stuff? I made a whole lot of mistakes, and I don't think everyone should have to climb the same painful learning curves, so that's why I write books.
well, again, Carl, thanks again for another great presentation. We'd also like to thank everyone for attending today's Modern Analyst webinar. And a reminder that we'd like to remind everyone that today's webinar, along with the slides, will be archived at the ModernAnalyst.com within 2 business days. We'd like to thank everyone for attending today's webinar. This concludes the event, and have a great rest of your day.
Thanks. Bye-bye.